Hello, welcome back. This is one of two extra bonus videos where we talk about more details about the Arduino board than we had mentioned before. Things that are not necessarily critical for you to know if you're doing basic and beginner things with the board, but if you're curious about more features, maybe this will be interesting to you. So I want to talk about a few different components on the board that are kind of neat. The first one I want to talk about is this thing right here, which is a funny component. It's the only one, well, I guess it's kind of like the USB. All right, I take it back. It's like the USB and like the capacitors in that you see there's like a little metal case, a little canister basically. And this canister is labeled. Of course, it's useful to look at the label, so let's take a look. I'm going to try to get it in focus. It says TKD 16.000. Okay, not necessarily super informative, and yours might, by the way, not say precisely that same thing. But what does that mean? Well, I want you to think about a pendulum. A pendulum is a thing that hangs like this, and when you push it, it swings back and forth like that. And the amount of time it takes to swing back and forth is dependent on the length of the string, the length of the arm of the pendulum. Not on the mass, just on the length of the arm. A longer string would take a long time to swing back and forth, whatever is at the bottom, and a shorter string would swing back and forth more quickly. So, keep that in mind. If you and I were to wonder, when is something happening? The most precision that we would need for most everyday applications would be to the minute, maybe even to the second. So when is this thing happening? This thing is happening at 4:02 p.m. and 36 seconds. That's when this is happening. When's the next happening? Maybe it would start at 37 seconds. And of course we can divide seconds into pieces, but on a human scale, time does not need to be subdivided so finely most of the time. So a second is a reasonable division for us, and a second is a reasonable amount of time for a pendulum in a clock that we're going to look at to swing back and forth. 1 second increments, pretty good. If you're an Arduino and you're waiting 1 second between doing things, you're going to be running very slowly. So let's imagine we tell the Arduino, please add 2 numbers up, and it does have the ability to add and multiply and do all sorts of mathematics on board. The way it actually achieves that is very complex, but essentially we can imagine a sequence of steps. So to add the numbers, it has to look at this number in this little piece of memory, look at this number stored in this piece of memory, and do some operation to add them up, and then store the result somewhere. That process would occur in steps. How often should the steps happen? The other thing is it has to line up many processes that are occurring in different parts of the chip simultaneously, more or less. So it's important to have a clock for the Arduino. The question is, how fast is that clock going to tick? And that is what brings us back to this little canister. Inside the canister is a small thing that physically vibrates back and forth. It is an oscillator. That's the name of the component. It's also called a crystal. And its job is to be a clock for the Arduino, a reliable high-speed clock. Now this one says on it, we read 16.000. What that's actually referring to is 16.000 megahertz, millions of hertz. 16 million hertz, which means 16 million times per second. There is a thing, and this is not a metaphor, there is a physical thing inside that metal box that is vibrating back and forth. I would not think of it string. It's not loose like this. Instead, it's more like a little diving board, something bouncing up and down that fast. But it's essentially the same idea, and it's vibrating about 16 million times a second. And the Arduino chip is able to look at that thing, or rather get an electrical signal from the thing, which changes 16 million times a second, and keep track of all the ticks and the tocks. So that's that thing. It's pretty remarkable. It's tiny, it's quite accurate, and it is used for timing operations in the brains of the Arduino. Another thing I'd like to show you, which I think is kind of neat, is there's another chip here. It doesn't really look like this chip. They're pretty different in volume as well. And this leads to an interesting point. In electronics, it's very possible to have one device or one type of device in different what are referred to as packages. And you could think of it like a package as in like a box around a thing. So this is a very small, what's called a surface mount package. This is a much bigger through-hole package, so-called because it's able to stick through holes like these are holes in the board. This one's actually got a little socket it's sticking into, but you can see the legs coming out of them. They're sticking down like they're going to stick through a hole. This package may contain truly the same electronics, which is surprising. Why would you have such a big version and such a small version? Well, there's different reasons. You might want a version. A human being is going to place that somewhere or solder it somewhere. And a human being has fingers of a certain size. And even if you're using tweezers, the smaller things get, the harder they are to manage. So this is another chip. And I just the thing about packages because packages or the size of the thing can be deceiving in electronics. Sometimes a very small thing can actually have a lot of complexity inside of it. And in fact, this is another microcontroller. And if we look closely at it, it says, who made it? Atmel. We know them. That's the people who made our other chip. And below that it says Mega 16U2, and then it's got some other date codes and stuff. So this is a different microcontroller on board the Arduino, in addition to the main Arduino brains. Well, why would we have two? The reason is, and this is a good example of where looking at physical positioning can be a really good clue in electronics sometimes, not necessarily, but sometimes. This chip is close to the USB port. It is also close to these little TX and RX lights. So it turns out that this chip speaks USB and translates that to the Arduino and vice versa. It talks to the Arduino, turns it into USB language, and sends it out the USB cable. When this little chip is talking to the computer, it is lighting up the TX because the Arduino is at that moment transmitting data. And hearing data from the computer, it's lighting up the RX lights. These 6 little pins up here, those are actually connected to this chip. They are a way to program that chip, not something you normally do. If you somehow wanted to change the way it was communicating with the computer, that's how you would do it. You would plug wires into those 6 pins and you could reprogram instructions for the chip. Finally, before moving on, I just want to note that all of these things are on a structure. And if I turn it over, it can be a little bit more obvious because there's a little bit less stuff going on. And I'll hold it at a little bit of an angle. This whole thing is called a PCB, for short, which is a printed circuit board. And what it is actually a whole bunch of electrical connections made by machine onto a piece of material. And you can see the thickness of the material here. The material itself does not transmit electricity. It is an insulator. But all these little bumps, all those little bumps are essentially very small wires that are running from one place to another. So we can follow, let's say this little small bump runs from here, over there, around here, to there. So there's essentially a little wire connecting here to there. That wire couldn't really easily be moved. It's pretty well static and fixed, like this kind of wire, which we would use to rearrange things. So a PCB allows an electronics designer to say, I want this connected to that, this connected to this connected to this, kind of lay everything out, and then you simply have to put the parts in the right places and the connections will be correct. When we're building circuits, certainly at least to start with, we're going to be using wires like these. We will make those connections ourselves. But you can really just think of this as a whole bunch of connections in a tight little package that keeps everything stable and secure and rigidly connected. Finally, I would mention that if you're curious about the components on this board, this is an open source project. The is open source hardware, which means you can actually access this board design online for free. Legally. It's not stolen or anything. It's openly shared. And to do that, you just go to arduino.cc and you can actually get the hardware designs. You can get the electrical schematics, you can get the board designs. And so you can basically answer to any question you may have about the particulars of this board. In the next video, I'm going to talk about all of the pins that I didn't mention in the first video, because there's a few pins that have various exotic or functions, less commonly used functions, that you might be interested in.